Welcome, Algebra 1. This is section 3-1, Inequalities and their graphs. The essential question is, when graphing an inequality, how can you determine the direction of the arrow? Let's begin. So you might have seen this before. I think I did it in a different lesson, but I'm going to do it again. So write down this table. These are inequalities right here. This is the word sentence that corresponds to the inequality, and I'm going to graph it. So the first one, inequality of x is greater than 4. You say x is greater than 4. And the graph of that is going to be an open circle at 4, and since x is greater than 4, when greater than 4 it goes this way because that's the bigger than 4 direction. So you're going to open circle at 4 and then draw an arrow. This looks terrible. You're going to do an open circle at 4. I'm going to do this in a different color. Blue. Open circle at 4 and then the arrow is going to go this way. Alright, the next one. X is greater than or equal to 4. So that's how you say it, greater than or equal to. I'm going to do a closed circle. Or equal to means I do a closed circle. And greater than means I go to the positive direction, so I go up that way. That is the greater than sign. Alright, x is less than 4. So when x is less than 4, I do an open circle at 4. And less than goes in the negative direction. So my arrow is going to go to the left. And x is less than or equal to 4. Well, or equal to means I put a closed circle at the 4. And then less than goes in the negative direction. So make sure you can say the sentence and then think about, well, if I say x is less than 4, the arrow should be going less than 4. If I say x, the variable, is greater than 4, it should be going in the higher direction. So whenever you're thinking about which direction it should go, just read it to yourself and try to understand. Like, okay, greater than means number's bigger. Does it make sense to have 5 bigger than 4? Yeah, so that means it's greater than. Another thing with the inequalities. A solution to an inequality is any number that makes it true. So I have this inequality here. 2x plus 1 is greater than negative 3. I want to find out if certain numbers are solutions. So on the left, I'm going to check, is negative 3 a solution? And the way I'm going to check that is I'm going to substitute negative 3 in for the x. So instead of having 2x plus 1 is greater than negative 3, I'm going to have 2 times negative 3 plus 1 greater than negative 3. So if you plug those in, 2 times negative 3 is going to be negative 6 plus 1 greater than negative 3. And then my next step here is I'm going to combine like terms at negative 6 plus 1 is going to be negative 5. Negative 5 greater than negative 3. Is negative 5 greater than negative 3? Well, negative 5 is actually less than negative 3 because if you go to a number line, negative 5 is going to be to the left of that. So is negative 3 a solution? No. Now we're going to check, is negative 1 a solution? So I'm going to plug in negative 1, so it'll be 2 times negative 1 plus 1 is greater than negative 3. So if I plug in negative 1, 2 times negative 1 is going to be negative 2 plus 1 is greater than negative 3. And my next step there, combine negative 2 and 1, so that'll combine to negative 1 greater than negative 3. Is negative 1 greater than negative 3? Yes, it is. Because negative 1 is actually a bigger number. It's than negative 3, so that is true. So I say yes. Let's try some examples. So pause the video. Alright, let's begin. So write an inequality, I should have said inequality, an inequality that represents a statement. So read this out loud to yourself. All real numbers x less than or equal to negative 7. So x is my variable, so I'm going to write an x. And I got to have all numbers that are less than or equal to. So less than or equal to negative 7. So I'm going to say negative 7, and I want to have numbers, well, I got to have numbers that are less than or equal to negative 7. So less than negative 7 is like negative 8, negative 9, and negative 10. So x is going to have to be less than or equal to negative 7. And that makes sense because it's got to be negative 7 and everything below that. So x is less than that negative 7. Let's try the other one. 6 less than a number k is greater than 13. So we're going to create this 6 less than a number k. So when I say 6 less than a number k, k is my variable, and 6 less than k is going to be k minus 6. And it says, the next part of this says is greater than. When I say k, this is greater than, so greater than is that symbol, and then is greater than 13, I'm going to put 13. So 6 less than a number k is greater than 13, and this is my statement. Next one. Pause the video. So which are solutions? They have 4 different numbers here, so we're going to plug those in and see if they are solutions. So the first one's going to be 13 minus 7 times negative 1 is less than or equal to 6. So negative 7 minus 1 is going to be positive 8. So 13 plus 8 is less than or equal to 6. 13 plus 8 is 21. Is 21 less than or equal to 6? No. Try the next one. Let's go to 0. 13 minus 7 times 0 less than or equal to 6. Well, anything times 0 is 0, so we get 13 minus or plus 0. It doesn't matter. It's less than or equal to 6. That's going to be 13 less than or equal to 6. Is 13 less than that? No. Let's try the next one. So I'm going to have 13 minus 7 times 1 is less than or equal to 6. So 13 minus 7 times 1 is minus 7, less than 6. 13 minus 7 is going to be 6. Is 6 less than or equal to 6? Yes, it is, because it's equal to. Now the last one for number 3. So 13 minus 7 times 3 less than or equal to 6. I'm going to get 13 minus 21 is less than or equal to 6. 13 minus 21 is going to be negative 8. Is negative 8 less than or equal to 6? Less than or equal to 6? Yeah, because negative numbers are always less than a positive number. Try the last examples. Pause your video. Alright, we just want to graph these. So x is less than or equal to 2. So whenever you're graphing at negative 2, I'm going to put a circle. I'm going to put a circle at negative 2. Now you have 2 options. You put an open circle when it's less than or greater than, and you put a closed or filled in circle when it's less than or equal to or greater than or equal to. Since there's no or equal to part, it's just going to be an open circle at negative 2. And x is less than negative 2, that means x goes in the negative direction, so it's going to be in this direction. So I draw a perfectly straight line that looks neat. Put an arrowhead there. That doesn't look neat at all. And that's my graph. Next one. X is greater than or equal to 5. Well, it's or equal to means I do a filled in circle F5. And then greater than 5 means bigger than 5, so I go in the greater than direction, which is to the right. Alright, that's your answers. Done.